Crazy math nerd here, Kitty Morgan, trying to shed a little light on this calculus fun stuff. So what is the second fundamental theorem of calculus and why will we use it? Well, here is the second fundamental theorem of calculus. It says if you take the derivative of an integral that is evaluated from constant to some variable, let's call this f of t dt, that this is just equal to the function at x. So, does that make sense? Well, you've gone forward and then you've gone backwards. It's like you're taking the derivative of the integral, so it's like you're going forward and backwards. And so it kind of does make sense you would just end up with a function. So let's see if you believe me or not. So I'm going to do an example. I'm doing this example so you never, ever, ever do it again, because I'm going to show you it works, and then you just got to believe me after that. So what if I took the derivative from 0 to x, and I'm going to do something I can integrate real quickly. And I got to do this in terms of t, so let me erase that. Okay, so t squared dt. All right, so let's do the integral part first. So I'm going to leave the d dx there. And if I integrate that, I get t cubed over 3 from 0 to x. And remember, you're taking the derivative of all that. So then if you take the derivative of this, let me evaluate it first. If you put x in, you get x cubed over 3. And if you put 0 in, you get 0. And then if you take the derivative of that, you get the derivative of x cubed over 3 is 3x squared over 3, which cancels, which gives you x squared, and the derivative of a constant is 0. So, oh my gosh, if you take this little value right here and you plug it into that, that is your final answer. It's this function, but the t is replaced with the x. Okay? Now that's if you have a simple x. What happens if it gets a little goofier? Well, there's like a chain rule part, I'll call it that, to this. And that is if you take the derivative of an integral from constant to function, and we'll call this g of x, so I don't get confused because I do that very often when I try to use the wrong thing, that the answer to this will be the function with g in it. Oh, kitty. Sorry. It'll be the function with g in it, and then because it is a function and I'm taking the derivative, I have to do the chain rule. So I have to take the derivative of that function. Okay? So how does that work? I mean, like, people are going to come up to you on the street and ask you this question. You're going to know the answer. Isn't that exciting? So let's say I had sine x here. I'm just making something crazy. And I have e to the t dt. So the answer to this, because I'm taking the derivative of an integral evaluated from constant to a variable function, is you take the function and put it into the variable of the integrand. So e to the sine x. And then you take the derivative, see there's that part, and then you take the derivative of sine, which is cosine. And you are done. So I know that seems real simple and easy, but if you never seen a derivative and an integral mixed up like that, you wouldn't know what to do. And in the next couple of videos, we're going to use this to help us solve some problems. So I hope this has helped.